Hi, I'm going to take you through some notes for the important parts of week 5. So the theme of week 5 is elements of an outstanding graph. So I want you to have some great notes for that. So when we're talking about graphing, I want to put that into a larger context. So we graph to represent a relationship or a function. But graphing is just one way that you can represent a function. We can also represent it as an equation or a table, or we can represent it as a situation in words. So we can represent the same relationship in all these different ways, and eventually what we're going to want to be able to do is move easily between these different formats. So if I'm given an equation, I want to be able to create a table, a graph, or a situation. If I'm given a graph, I want to be able to figure out an equation from that graph, or a table, or a situation. So that's where we're headed, but our focus this week is on the elements of an outstanding graph, so we're really clear on that. So there's a few notes that I'd like to take on a couple different parts of an outstanding graph. And the first would be about the axes of the graph. So the first point under axes is that they're usually darkened lines. Darkened lines. You can read that hopefully. And they go on forever, so they end with arrows. And the arrows at the end of the lines indicate that they never end. And the second thing that has to happen with your axes is they must have labels. They have to have labels. And when you're given a situation, it should have a description, like time, and units. So you have to have both parts for a good description. So I've made a axes here, and you can see it's just plain grid paper. So I had to darken the lines and make my own axes. And so if you don't have a context, you could always just label it the X and the Y axes. But if you do have a context and you know what those variables are, so for example, let's say that we've got time and we're going to measure that in minutes. And then over on the y-axis we could have, let's say, distance, and we're going to label that in miles. Okay. So that would be what your ideal axes would look like. Now the second thing that I want to talk about is scale. Okay, and so scale is how you determine the numbering system on your axes, right? So I have boxes, and I could just say each box is worth 1. That would be the easiest way, but sometimes that doesn't fit with your situation. Let's say I knew that my situation was going to include time that went up to 60 minutes. So let's say I wanted to include a full hour. So if I knew that my inputs were going to be from 0 to 60 minutes, then I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 or 9 boxes here, so using ones would only get me to 8 or 9 minutes. So I have to use something bigger. So I could try tens. 5. Well, if I tried fives, I wouldn't quite have enough either. So I might have to do tens. 10 minutes, 20, 30, 40, 50 minutes, 60, and then I usually go just a little bit over, right? And that way I'm sure that I can fit all of my data. But for miles, maybe it takes me 10 minutes to go 1 mile. So I wouldn't want to use the same scale on my y-axis. So let's say I just need to go from 0 to 6 miles. Well, it wouldn't make sense to use the same scale. If I made this first box equal to 10 miles, that wouldn't make sense. My graph would be way too small. So in this case, I'm just going to count by ones. 1 mile, 2 miles, 3 miles, 4, 5, 6, 7. And so then I know I can fit all of my data into my box based on the scaling. So the way we describe this for scales is we say it needs to be appropriate, and that means that it fits your data. And you can show the minimum to the maximum of your range and the minimum to the maximum of your domain. Unless it goes on forever, obviously, and then you just need to use the arrows to indicate that. Your scale should also be, I'm going to just put it over to the side here, ethical. And so your scale should not distort your data. And I've given some examples in the classwork today of scales that distort the data, but you want the data to be clear and an honest representation. All right, 2 more parts to consider for an outstanding graph once you've got your axes and your scale, because really, I mean, that's the first 2 parts, and really that's all set up, right? That's all just setting up your axes, labeling your axes, and finding an appropriate scale to represent your data. We haven't actually done any graphing yet. But what you want to focus on now is labeling the important points. So points, you always need to label the important points with a dot and an XY point. And so one of the key points that we talk about is the y-intercept. Oftentimes the x-intercept is important. That would be another one to label. And then any given points. So if in a situation, if you're given an XY coordinate, you're going to want to mark those on your graph. So if we go back to our grid, and we could say that I'm graphing how many miles I can go. So after 10 minutes, perhaps I can go 0 miles. And after 20 minutes, maybe I can do 2 miles. 30 minutes, 3 miles. And then I can go backwards to 0 minutes. I would be at 0 miles. So I'm going to make sure my x and my y-intercept is the same point here. So I'm going to just use a different color and mark that as 0, 0. And then I don't necessarily have any other special points that need to be labeled, but I've got kind of enough points there to recognize a trend. So then the last thing for your outstanding graph would be your accurate lines and limits. So your line is going to connect your points with a straight line. And the other thing you have to pay attention to is the endings of the lines. The ends of your line are important. So they can either end with a dot or with an arrow. Oh, that's not an arrow. Right. So a dot means that there's a limit. There's an ending point of your line. So a dot means a limit, or could be an ending or a starting point. And an arrow means it goes on forever. Right. So if I were looking at my graph here of miles versus time in miles, I could create a line that looks like this. And so on this is indicating that it goes on for a while longer, right? So somewhere else, so unless I wanted people to think that I could run forever, nonstop, at some point, somewhere I want to represent that there is an ending point to this. So I might say off to the side that the domain, so a realistic domain, let's say I could run for 2 hours, would be from 0 to 120 minutes. So if your graph, if I can't capture that exactly on a graph, I could write my limits off to the side if I wanted to indicate that my line goes on for a little bit longer, but not much. And then down here, obviously I can't run backwards in time. I can't run negative 10 minutes, so there's not going to be any additional line back here, so it's going to end with a point. So hopefully that helps explain all the important elements of an outstanding graph. Thank you.